Hello, I welcome you all to this another interesting screencast. The problem reads that the car has a speed of 55 feet per second. Determine the angular velocity theta dot over the radial line OA at this instant. This problem is coming from the engineering mechanics dynamics 14th edition by R.C. Hibbeler. So for problems like this one, polar coordinates are suitable coordinates to use, and for polar coordinates the path is being defined by the radius r and the angle theta. Okay. Of course, we are still able to define the same path using rectangular coordinates, but of course in this case we are going to use polar coordinates, right, to find the angular velocity. So the direction for r itself is along r, like so. This is our positive direction in that manner, and this is our r, okay, with the unit vector in that direction u r, like so. Right, and then we have direction for our angle, which is theta, and the unit vector is u theta, like so. Right, so let's write down the expression. So we have r, okay, which is equal to 400 feet, okay, which is constant, right? So we know that for r itself it's not going to be changing, right? R dot or time derivative of r is going to be 0 because it's constant throughout the path. All right, so r is equal to 400, and then we know that our velocity, okay, our velocity is just going to be equal to Vr, okay, by the unit vector in that direction, and V theta times the unit vector in that direction. Okay, so you can check out on how to work out these particular derivatives. So we know that our Vr is just r dot, and this r dot is our dr dt, okay, and this is going to be equal to d, okay, 400 with respect to t, and we know this is equal to 0. And then we have v theta, okay, and v theta is equal to r theta dot, okay, which is just equal to r, okay, d theta with respect to dt. This is what it means. Right, so then our velocity, okay, because the two are perpendicular, v theta and vr, so our velocity, our magnitude of velocity, which is given as 55 feet per second, is going to be equal to the square root of Vr squared plus V theta squared. Okay, since we already know what these values are, our Vr, we said, is equal to 0, okay, and our V theta is equal to r, let me just write the actual number, okay, so this becomes a 400, this is just going to be equal to the 400 theta dot, so this is equal to 400 theta dot. Okay, so replugging them back there, we are going to have 55 squared is going to be equal to 0 squared plus 400 squared theta dot squared. Okay, and then later on making theta dot, which is the angular velocity, so this just becomes equal to, this becomes equal to 55 squared divided by 400 squared, and then everything under the square root. Therefore, this is equal to, working out this, we get the following. So we have 55 divided by 400 squared. Okay, square root of that. So we have a 0.1375 rads per second. Alright, so this is the final solution. We found the radial, the angular velocity. This is the rate at which the direction itself, okay, is changing with respect to time. Okay, so I hope the video was helpful. And if it was, give me a thumbs up. Continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.